going to set about explaining an approach to the narrative which gave rise to it, or to us, the humans. More specifically, I'm going to talk about the narrative that gave rise to me as you see me here now. And there are a couple of things that I need to clarify before I get into that detail. So, in the middle of the 19th century, Charles Darwin and Wallace, Darwin primarily presented what we know now as the theory of evolution. And that theory was a huge challenge to the religious or the Christian assumptions that prevailed in the Western world at that time, especially in Victorian England. Darwin was by no means a firebrand in how he presented to the world. He was a meticulous observational scientist, and he had taken elaborate notes and drawings based on his observations as the ship's biologist on the Beagle as it travelled around the world. And basically, what he observed was an enormous challenge to the Book of Genesis version of how humanity and how the universe had come to be. That basically suggested that God had created the entire universe over 7 days. I think he rested on the seventh day. And that had formed the basis of the Christian view up to then, and for many still does. Darwin basically came up with the idea of what we call natural selection, and nearly 2 centuries now later, a huge amount of further scientific research in the interim has given us the gene and genetics and the understanding that to a large extent we present to the world based on what our genes have endowed us with. So I'm naturally tall, I've got an underreach, I've got naturally curly hair, and a bunch of other characteristics that have been endowed upon me through my genes, given to me by my mother and father, and given to me by their different genetic legacies. The very simple classic example of evolution or natural selection lies in why giraffes have long necks. So basically, the giraffe as we know it now would have evolved from a shorter necked version back in the day. But giraffes are largely leaf eaters, and so those who are endowed with a slightly longer neck have an evolutionary advantage in the environment, and so they survive above their shorter necked kin, who can't compete with them when it comes to accessing food. Giraffes are not famous for sharing, and so on and so on. The longer necked kin prevail and reproduce and pass their characteristics on to their offspring. But even within that, genetic mutations and the like will give rise to giraffes who have slightly longer necks all the time. And so we now have the situation today where we have these magnificent beasts who have long necks. Every aspect, since Darwin and Wallace rocked the world with their presentation of evolution, a huge amount of further scientific research has given us more detail of that story. So human life as we know it, or all life as we know it, is in the ballpark of 4.5 billion years old. It began on the surface of the planet Earth, most likely elsewhere in the cosmos, but this is all we know for now. And it began in what was called the primordial soup, and certain chemicals emerged in that nutrient-rich soup or liquid, the basis of which was water, H2O. And so the first living things came into being, and these consisted of very primitive life forms, which like modern day viruses consisted of strands of DNA, or often hoops of DNA, surrounded by protective protein shells, sometimes layers of fat, as is the case with the coronavirus. And from these, over 4.5 billion years, life on Earth as we know it now evolved bit by bit. The fundamental dynamic being that it's gene driven, and Richard Dawkins talks about the selfish gene. So basically our genes endow us with characteristics which may or may not give us an advantage in the environment, but if they do, we survive accordingly and procreate, or either sexually or asexually. And so these characteristics are carried on, and the gene that endowed us with them is preserved. And so we have gone from these very primitive single-celled entities to multi-celled entities like myself. But if I have a thesis to present here, it is not so much to present or to talk about evolution per se, but it is to talk about the entire cosmic narrative that has given rise to us. So just to do a brief diagram here. So if we consider that, let's say, there's the mark which points to the start of life on Earth. So life on Earth begins here. Life on Earth begins here, and between the time that the very, very first primitive life forms emerged and this point in time where I'm here now presenting this to you, the time period is roughly, so here's now, and this is 4.5 billion years. Yeah. Many people in the scientific world and elsewhere choose to understand the story of life only in those terms. Yeah. So what I'm going to advocate is a theoretical approach that takes cognizance of the roughly 9 to 10 billion years that went before that. So right back to what we call the Big Bang. Okay, so here's the Big Bang. Such graphics. There's the Big Bang, and all this time, roughly, I'm gonna say 9 billion years. 9 billion years of what I would call cosmic unfolding. Nine billion years of cosmic unfolding went on before the first life forms emerged on planet Earth. So it's perfectly valid to consider a narrative that begins with the very first life forms here. But in my view, it gives a much clearer explanation to me about how I am and about how I function in the world, and about what I observe in humanity in general. Gives a much more substantial explanation and understanding of that if we go right back to the Big Bang. And if we consider that in the first 300,000 years after the Big Bang, there was nothing in the cosmos except hydrogen gas. So Hydrogen. So we're just talking about this early period here. So we just had the hydrogen, nothing but hydrogen gas in the cosmos then. If you needed a word, you'd only need one word: hydrogen. There was nothing else. And people may find it hard to accept that everything we now have, myself included, this whiteboard here, this marker, the entire cosmos, everything we can see, everything beyond what we can see and experience, all began or all came out of that vast ocean of hydrogen gas. Yeah. Just one thing in the cosmos at that time. And the next thing that happened continues to happen today and continues to be of enormous relevance to us as it happens. So it's effectively the first step in the journey that led to us. And what did that involve? So very simply, if you like, let's say we have two atoms of hydrogen. There they are. And they fuse to give an atom of what we call helium gas. Okay. So we use in science what's called an atomic number. So the hydrogen has atomic number 1, and since the helium is the equivalent of 2 hydrogens, it has atomic number 2. Yeah. That may seem very remote and sciencey. I'm making this video here. I have no artificial light, so the light by which you can see me here is the light that comes from that particular reaction, and that goes on all the time in our sun. I was going to say every day, but they tell me it goes on at night as well. Okay, 2 hydrogens fuse in a very extreme environment of energy, the kind of environment that we have in our sun and elsewhere in the cosmos, to give a helium atom. Now, they tell me actually that there are 5 hydrogens in total involved in this. But what emerges is the equivalent of 2 of them. The rest are turned into energy according to Einstein's famous equation, E equals mc squared, and, well, hence our sunlight. But this is the first step on the journey to you, me, and everything. So this system then of what we call nuclear fusion, it's what goes on in the stars, and it gives rise to, in total, 92 different kinds of atom. So down here we have 92 atoms, and they make up what's called the periodic table of the elements. And the biggest of those is uranium. It's the equivalent of 92 hydrogens, and it is unwieldy and inclined to fall apart. Okay, and that's another day's work. So the next phase, we only mainly know from the surface of the planet Earth, and basically it involves a different kind of assembly of available entities to give us the whole world of red marker. I hope it works. Yay. Okay, gives us the whole world of the molecular. So we have the atomic, we have the original hydrogen phase. We might have another phase prior to that we would call the pre-atomic. Then we have the molecular, and it involves a different process of assembly that can happen in an environment of much lower energy, the like of which we have here on the surface of the Earth. This molecular phase could not happen in stars, for example, although it probably does happen to some extent. Okay, but basically we can only have 92 different kinds of atom, although there are other atoms that have been man-made in the lab that last only milliseconds. But at the molecular phase, the atoms assemble in a different way that does not require the extremes of nuclear fusion to give what we call molecules. Okay, so I'm going to say millions of molecules. Millions of molecules. So there are some classic molecules of which we know. So water. Water is 2 hydrogens, H2. So H, and in the middle we have an oxygen. Now, so the atomic number of hydrogen is 1. And the atomic number of oxygen, I think, is 8. Could be wrong there. Anyway, if there was nuclear fusion involved here, we would end up with some kind of an atom. But the assembly here, if you like, is not based on an assembly of nuclei. It is based on an assembly of electrons which, if you like, orbit the nucleus of any given atom. So it is on the basis of a sharing or a swapping of electrons that we have this kind of assembly. common table salt, NaCl, sodium and chlorine, so that's salt. Sodium and chlorine are two of the most noxious things in the world, but when they assemble in this way, we get common table salt, which we can sprinkle on our dinner. Carbon dioxide, we're familiar with that, very much in the news at the moment. CO2, two hydrogens here will fuse at the nuclear level, or the level of nuclear fusion, to give a helium atom, but if they fuse at the molecular level, we'll get a molecule of H2, yeah, two hydrogens bound together on foot of a sharing of electrons. All right, so from this the next phase of this journey involves yet another kind of assembly, a system of assembly, and it's at this point here where what we know now as life on Earth starts. And so it is largely built around one extraordinary type of molecule called DNA, or deoxyribonucleic acid. So, the very first living things are built around this molecule, yeah? And it has two extraordinary capacities. First of all, the DNA molecule can act as kind of an alphabet which stores information. So it has 4 letters, adenine, guanine, thymine, and cytosine. And those 4 letters, if you like, can be used to spell out different characteristics that we find in different living things. And it can dictate to the environment around it to make things based on the characteristics that it spells out. Now, there's no deliberation in this. It happens by accident, basically. And they say that life on Earth evolved on foot of a very elaborate series of accidents that went on over 4.5 billion years. But the DNAs that survived were basically the ones that could build little environments around themselves, and consequently could grow bigger and longer. And then the other extraordinary characteristic that DNA has is that it can divide. So it's a double helix. Each side of the helix contains, if you like, the entire code. And the helix can split up and carry all the information exactly intact to a new, it's like one half of the cell goes with one strand of the DNA, the other half goes with the other strand, and in time a double helix is re-established in each new daughter cell, yeah, and each new daughter cell consequently has all the characteristics of the parent. So how did we come about? Well, we came about because the DNA was prone to accidents, which are called mutations, and these mutations gave rise to new characteristics. and if those characteristics bestowed an advantage to the organism that contained them in the environment, then that organism would survive and would reproduce and and would bring these new characteristics with it until basically it was superseded by other organisms which were better equipped than it was in terms of available resources, etc. So at this point then you had a whole world of what we call single-celled entities, and then basically cells which managed to cluster together in the aftermath of division. They began to have an evolutionary advantage, of course, and within the cluster different cells developed different specialities. So if there were cells in the cluster that had a light sensitivity, they would in time become eyes. Cells that protruded and were inclined to move became limbs, and so on. And consequently, 4.5 billion years after this point here I am, here you are, and here the whole world is as we know it. So basically many people see the theory of evolution, or the idea of evolution, and the whole narrative of the emergence of life on Earth as being the only relevant narrative when it comes to discussing living things. What I'm going to offer here is a thesis that relates to the entire narrative going back to the Big Bang. And there are a couple of things that I will deal in the next episode here. So there are a couple of things that I would like to talk about in regard to that. So if I were to say that I and my world are consequences of this roughly 14 billion year old narrative, I'm going to ask to what extent is any aspect of that narrative concluded in our experience. So I'm going to say any conclusions. Okay, so there are many, especially in the world of science, who would treat things like evolution as a conclusion, oddly, and presume that if we progress, that we still progress on foot of what I would call classical evolution. So I'm going to put a little marker here towards the end of this storyline where the human emerges. Okay, and if you like, so I'm going to say, are there any conclusions in any of this? The concept of the rational, many people treat as a conclusion, as if it is some kind of zenith of development in the living domain. So is there something more effective beyond the rational? So if we have evolved or come to the rational, is there anything beyond that? Are we only required to be rational and scientific? That is a fundamental question here. And so I'm going to suggest that the story is not over with humanity. So story not over with the human. Okay. And I'm also going to suggest that even though the story up to the emergence of the human is built on a dynamic that proceeds from the gene, that a lot of what we observe in the human realm would seem to suggest that a part of humanity involves us being at odds with our own genes. So this book began its days as a book about acting. I'm an actor with a background in the sciences, and what interests me about acting is that we are given to treating ourselves as malleable or changeable, or we are, I was going to say, we're given to playing with ourselves, another day's work, but what we are certainly given to doing is exploring play within the experience of self. So we will treat any aspect of the human presentation that is changeable, we will treat it as such. So we will change our hair, we will change how we look, we will make decisions about how we present to the world, often at odds with our own genes. And we also choose to set aside the dynamics of the evolutionary dynamics that go with the gene, basically, or that are dictated to by the gene. Okay, so I'm going to call this period here then the period of classical evolution. Okay, and I'm going to call that phase of cosmic unfolding that tallies with the emergence of the human being as the neo-evolutionary phase. The neo-evolutionary phase. And so basically what occurs to me, many people will say that the universe doesn't care about what you think or how you feel or anything like that. Of course, that is to some degree partly true, but it overlooks the fact that I myself am part of the cosmos, and I care about what I think. I care about myself. I care about other people and things. So, in as far as I care, the cosmos does, in that small sense, care. And the other thing, of course, is that you could say then that that the cosmos has evolved or progressed to the kind of capacity to act that I find in myself. Okay, so this is the end of episode 1, and I'll post up episode 2 shortly. Thank you. Bye-bye.